So in this little screencast, we're going to work through how to calculate the standard error and to apply the standard error to find the probability that a certain predicted sample mean is within a range of a population mean. So first of all, here is the EAI data of annual salaries. Now this is a big data set. There's 2,500 different bits of data in here. So let's just summarize it. We'll go to data, data analysis, and then descriptive statistics. And we want the cells, we just want annual salary, so we go from B1 down to the bottom, which is B2501. We have labels in the first row, and we want summary statistics, so we go OK. And let's put it in a new worksheet. Alright, now here is the summary statistics, which is what we're going to work from. I get a bit larger. There we go. Right, first of all, we're going to calculate the standard error for a sample size of 30. So remember what the standard error is. The standard error equals the standard deviation divided by the root of n. So let's calculate that for a sample size of 30. So I put n equals 30 because we're going to try it with a different one later. So we want to get the standard error. So I put SE here, and what we want is equals, and the standard deviation of the population is 4,000. Click that in. Now we're going to divide it by the square root of 30. We're going to put in 30. So type 30, and to get the square root, you can click that little arrow thing, caret or what it's called, and 0.5. That means to the power of a half. And that gives us our standard error of 730.296. Now we want to get within 500 of the mean. So that's going to be the mean minus 500 and the mean plus 500. So let's just do that here. So we're going to go equals 500 as the mean plus 500, and then we want to do it the mean minus 500. So type in the mean minus 500. So in other words, we are trying to estimate between 52300 and 51300. So let's now work out what we've got to do. So look at the sketch on the blog, and we need to find out the probability of our sample mean being between 52300 and 51300. So go equal norm dot dis, that's for Excel 2010 has that dot in. Now we want the first one between, so that's going to be on the top side 52300, comma the actual population mean, comma the standard deviation of our sample of 30 we just calculated, put that in, comma, and then put in true because it's cumulative. So the area to the right hand side up to 52300 is 0.753. Now we want in between 51300 and 52300. So let's do the left hand edge of it, equals norm dist. Now we put in the first one here, comma, the mean again, comma, the standard error of our sample, comma, and then true. So it's between 0.2467 and 0.753. So go equal. Let's subtract one from the other. So here's the result. It's not too good, is it, right? So we've got a 50-50 chance of the sample mean being within $500 of the actual true population mean. Now let's try it with n equals 100. And you should be able to do this at home, right? Okay, so now we need to recalculate the standard error. That's very important because we've got a different sample size. So go equal, and then our population standard deviation 400 divided by 100 to the power of a half, which is a square root. So that gives us a new standard error of 400. So now we go through the same thing again, equals norm, sorry I must forget that dot, dist. Sorry, we're out of the area of the recording, I have to go down here. I'm going across here, okay, don't get lost. Equals norm dot dist. And then the first one is 52300, comma, the mean, comma, the standard error, comma, and then true. Oh, okay, so this is the right-hand edge when we have a standard error of 400. Now we need to do the left-hand edge, equals norm dot dist, comma, this one, 5120, comma, the mean, comma, the standard deviation, comma, and then true. Okay, so now we've recalculated it. Now subtract again. Okay, 0.7887. So in other words, you can see the probability of our sample mean being within 500 of the population mean has increased very markedly, hasn't it, to getting on for 80%, because we increased the sample size from 30 to 100. So what happened was that as we increased the sample size, the standard error decreased. Remember what the standard error is? The standard error is it's the square root of n underneath. So as n increases, it doesn't matter whether it's a square root or anything like that. As n increases, the standard error decreases, and so we get more accurate. It's intuitively correct, isn't it? The bigger the sample, the more accurate you'd expect it to be. Thank you.